Hello, am I audible? Hello, I'm audible. Okay. Thanks for giving me break because break is important to re-energize yourself. Now I will do deliberately for 40 minutes. After that, I have to end because otherwise my I'm in hostel and my I will miss my meals. That's why I 40 minutes have to complete. Uh-huh. Basically, what we did this I have explained that every reassignment, the further step reassignment objective function will be less than earlier step objective function, because what we are doing is the purpose is for the purpose to minimize this objective function, that in each cluster the distance between the mean and that point is minimized all over the data points wherever the data points has been assigned. Wherever the data point has been assigned. Initialization, randomly assign the data point. We have discussed this. We have discussed this also. No, we have not discussed this. We have time to discuss. Now, mu z t plus 1 mu z mu z t plus 1 mu z t plus 1 I is mu z matlab the assignment. What is we call it mean of the cluster, indicator of that point in which cluster it is. At t plus 1 iteration, basically we are converging. Basically, we are in every step we are checking that that point is nearer to which mean. Basically, what it will be. At teeth iteration, the distance of that point to the point which has from which it has minimum distance means zit plus 1. It is the reassigned cluster indicator which we have decided through this function, in which we are checking that for each point which cluster mean has the minimum distance. For example, if the point data point first has the minimum distance, uh, to the cluster. Earlier it was assigned to the cluster 4, data point 1, but now after checking its distance from each 5 clusters, each mean of the 5 clusters, we found that it has minimum distance from the second cluster. We will reassign that cluster indicator from 4 to 5. Basically, we are minimizing this function. We are trying to minimize this function. So at t iteration, what were the cluster indicator at t plus 1, we have updated the cluster indicator. For that mean, we are it mean distance will be less, mean of cluster where xi wants go to, and mean of the current cluster xi assigned to. No, last basically it is the cluster indicator for t plus 1 iteration. It is just the cluster indicator for t plus 1 iteration. But we at every iteration we have to, the mean is changed because the configuration has been changed. Many point has been gone out of the cluster and many point has come in the cluster. So mean has changed for every iteration, and we know that mean is the minimum distance from every point of the cluster. If we do summation, mean will be the minimum distance from every point of the cluster. We have proved here. Basically, this says that this says that we are minimizing our objective function at every step. At every step we are minimizing it up. We are doing reassignment, we are calculating the new mean after the configuration has been changed. And our main focus was to minimize this function, and you can see here at last this will be the configuration and it has the minimum value. It is less than this is less than this, this is less than this, and this is greater than this, and it is the t plus 1 iteration, and this is the objective function. When we calculate it, it will be the minimum. We have proved that the mean is the minimum. If we do summation from each and every point in the cluster and square the distance, the mean is that point which have the minimum distance, which has the minimum value for this function. We have done this by differentiating in the first interval. This is the objective function. Only this is the objective function still used after reassignment step. This was what I wanted to explain. Basically, this shows that it will converge after every step. Now that is the catch. Will give the global minima or global maxima? Basically, we can do something. Uh, Suppose initially we are here. I was called. I was called. So I now I am back. I have to do fast. So, basically, this is the point where I am, where the objective function is, and it is minimizing. It is going in this direction. It is going in. It is going in this direction. It is going in this direction, and it will approach in this direction. But after here, it will not, because it will reach the local minima, and this function is all about that. It has this type of graph, and this whole iterative step is all about minimizing the objective function. But it is for sure that it will minimize to the local minima, because it will go in the direction where the objective function is less. But after that, it will not be go able to go at basically, you can assume our function like this. It will be not able to go up, because every iterative step is sure that it is going down, and next iterative step can't assure that this will go up. This is the drawback of k-means clustering Lillard's algorithm. It gives the local minima. Oh, sorry, I was unmuted. I'm once again explaining. I'm very much sorry that it is. I can. I will. Uh, this is our basically feel that this is an objective function, graph of objective function. It is the objective function. If we take different reassignments, it will be the values of graph of objective function for every assignments. And we know that every step has has different assignments. So assume at first iteration where we were here, at second we were here, and it will be in the direction where the objective function will be minimized. Objective function will be minimized. Objective function will minimize. It will go there, it will go there, and we have proved that at each step objective function is minimized. But whenever we reach there, after that nothing will go, because every iterative step is only depend on that basis, that that next iterative step has minimum objective function. This minimum, this 1 minute, minimum, this objective function, every step is associated to that only. Each and every step is associated to that only. Every step is associated to that only. Every step is associated that way. That's the drawback of k-means clustering algorithm. Basically, that's the drawback of k-means clustering algorithm. It will not go up because it is assigned in that way. It will not go in this direction. It will stop at there if we start from there, because first of all we have taken the random assignment, And for random assignment, it can be anywhere, objective function value. So this is the this is the drawback of events clustering algorithm. I am removing. Hmm. I have discussed this. Now nature of clusters. Natures of clusters. Overnight. This is very basically. Hmm. Basically for any data point, can you define any regional difference, that any line, can you draw any line between this two mean that from basically from can you define any line that all the point in this direction will be the point of this cluster, and all the point in this direction will be the point of this cluster associated with that mean. Basically for points in cluster 1, basically for points in cluster 1 assumed x, its distance from the first mean will be less than its distance from the second mean. This is the whole equation, and it's give us this xtwb. This give this xtwb. It is the equation of line. It is the equation of line, and it is the equation of line. I have to erase this. It is equation of line. 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 You have listened. It is equation of line. We are trying to draw this equation, and this will give the cluster 1 region, and this will give the cluster 2 region. Here basically this is the equation of xt mx is equation of mx, and this is the equation of mx plus c. And for less it will be this, and for greater it will this. So we are trying to find the cluster 1. For the points in the cluster 1 will be this, for the points in the cluster will be this, for points in the cluster 1 will be this, and for points in the cluster will be this. This is the region of the cluster. For any point in this region will be in this cluster, for any point in this region will be in this cluster. This is basically this is the way we assign. This is the way we are assigning. This is the way we are assigning everything. And everything. Okay. Now this point is clear. For k is equal to 3, this will be the regions, Voronoi regions. The cluster regions are intersect of half spaces. Basically, spaces. This cluster. Basically, we draw a triangle between this, and we draw basically how to define. Basically, I will show you how we have defined this cluster region. Basically, this is if we have 3 points, and all the these points are mean, then cluster will be the perpendicular intersection. You know the perpendicular intersection. This will be cluster 1, this will be cluster 2, sorry, this will be the cluster 2, and this will same to same. This will be cluster 2. Sorry. This will be cluster 1 cluster. This will be other cluster, and this will be other cluster. Basically, it will the intersection of the perpendicular distance will decide the cluster space. This is Bernoulli region. How to fix spectral clustering? Initialization. Now we are trying to minimize the drawback of the first clustering algorithm. It is k-means clustering algorithm. Drawback was that it calculates the local minima. And why this local minima is calculated? That because we are taking, because at every step we are taking any random assignment, and random assignment can give the random objective function value. It can be here, it can be here, it can be here, it can be here also. If it will be here, it is the worst random assignment. If it is here, it will be the worst random assignment. If it is here, it will be little bit good, but it will the best assignment. So for that, k-means we have to do random assignments and check for every random assignment and give the least objective function for every k-means random assignment. It is a tedious task, so we need, the problem is in the random assignment. So here we have worked on that. There has been work on the random assignment part, so that drawback has been can be removed. First of all, we will see what is the random assignment. After that, we can give an intuitive way that how this random assignment is correct. uh, Basically, what is random? Choose the first mean uniform randomly. First, earlier we were assigning the every point any of the clusters. It would give the lack. It would give the drawback for the first k-means algorithm. But here we are not assigning every point. We are choosing k. We are choosing k mean instead of assigning every point a cluster. We are every point a cluster. We are choosing k mean. We are choosing first mean, second mean. We are choosing first mean, second mean, third mean, fourth mean. We are choosing mean instead of assigning the cluster indicator for each data point. This is the catch. Choice of k, want to k to be smallest as possible. No, this is there is something wrong. For this, from there we are here. Basically, we are choosing the probabilistic way. K means plus plus algorithm is little bit different. It chooses smart initialization k means plus plus. First of all, we will choose the it will choose first of all it will choose any first cluster, not all the k clusters. Mean any of the cluster mean. Assume we choose any mean which is the cluster mean of first cluster. We choose that, and after that every other cluster mean will be chosen probabilistically. How? I will show. This page are number assigned in wrong way. After that page we will come here. Here for we have chosen the first cluster mean. Randomly we have chosen the first cluster mean. We are trying to reduce the randomness because randomness has given us the drawback. So second cluster mean will be chosen on the basis of this probabilistic score. Suppose it will calculate, first mean will calculate its distance. First mean basically Sx Sx is the distance square between other remaining points except the first mean chosen point from that x n data points. It is the distance square, and we are trying to minimize. Sx will be the distance remaining from all the L minus 1 points. All the L minus 1 point, sorry, all the basically till now every data point is the candidate for the next cluster mean. So Sx is the minimum distance of every data point to the currently assigned means. Sx is the minimum distance between, basically I can example, till now we have chosen first cluster. Till I giving example. There we have 10 points. This is the cluster mean. We have chosen randomly 10 points. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Now we will check the distance. Check the distance. Check the distance. It is going further. So the second cluster mean Sx score will be less for this first data point and max for the last data point. Last data point. So Sx is the, for every data point, it is the minimum distance from already chosen cluster mean. So Sx for this first data point will be this, for second data point will be this, for third data point will be this, because we have only one cluster mean. So now suppose at second step we have got second cluster mean. So every data point Sx score will be minimum of these two, this distance and this distance, minimum of these two distance, this distance and this distance, which is minimum for this data point. 1 to L minus 1. Matlab 1 to, if you have already chosen two data points, so 1 and 2 cluster mean, we will check the minimum distance between, for every data point for already assigned cluster mean, will change what is the minimum distance. It will be its probabilistic score. And next data mean, next cluster mean will be chosen on the basis. Basically, it is, we are not assigning every cluster, every point a cluster indicator, rather than we are choosing k cluster mean. We are choosing k cluster mean. So we have x score and such as 20, 10, 20, and 30. And after that, 10 by 30, so 10 by 60. Suppose you have three data points, 20 by 60. This is the chance of x1 to be the next cluster mean, x2 be the next cluster mean, x3 be the next cluster mean. This is the probability of being x1 the next cluster mean. It is 1 by 6. x3 next cluster mean 1 by 2. It is the probabilistic way, and we are choosing it probabilistically. We choose the expectation of this, and further we will assign third cluster. After that, in next we will try to find fourth cluster mean. So for every data point, we will try to find the, for suppose this is the data point, we'll try to find the next SX score will be the minimum of these three lines distance. For every data point we calculate this, and again this calculated SX score at each iteration will give us the probabilistic view for the next cluster mean. So in this way we will choose 1, 2, 3, 4 K clusters. And how is it is intuitive, I will try to explain. How it is intuitive, I will try to explain. Basically, how it is intuitive, that the next cluster mean will be farther at farther distance from already assigned cluster mean. So we will choose, if suppose every data point has the minimum distance from any of the cluster mean already chosen, and all, if suppose you have three data points, three cluster mean chosen, then rest of n minus 3 is the proper candidate from the next cluster mean. So for next n minus 3 data points, we have to choose the next cluster mean, and we are taking its minimum distance from any cluster mean, and we are trying to maximize that. If any point will be at maximum distance from all three clusters, from the minimum of all three clusters, then it will be the next cluster. Basically, we are trying to distribute all the clusters at max space, max distance. So if it is, if Sx is the minimum distance for each point from any of the cluster mean, and here the probabilistic value will be higher for only that Sx value which is higher. Basically, we are taking the max of the minimum distance from any of the three cluster means. For every value of Sx. In basically, if we are, what will say, if we are farthest from the minimum cluster, we will be obviously farthest from the distance of maximum cluster. This is the point. Basically, suppose these three are the lines. If let us consider this as the new cluster mean. If it has Sx value, the largest from all of the data points, it is minimum from all three Sx distance, this distance. If it is farthest, then this data point will be obviously farthest from all other mean. That's the point. If we are at maximum distance from the minimum mean, it is obvious that we will be at max distance from the all other maximum mean. Basically, if basically I can explain. If we are nearer to Patna. And if we are from Ranchi, we are nearer to Patna. And we have to check the point which is at maximum distance from Patna and Delhi are chosen two clusters. Mean, already chosen two cluster mean. If we want to choose the next cluster mean, we will choose that point which is at a max distance from its minimum cluster distance. Basically, from Patna to Guwahati, if the Patna to Guwahati SX score is the maximum of all the chosen scores, all the distance, all the calculated score, SX from Patna to Guwahati will be minimum for Guwahati because SX score for Patna to Guwahati, and for SX it will be minimum from already chosen cluster mean, distance from the minimum of the already chosen cluster mean, the distance between Patna and Guwahati and distance between Guwahati and Delhi, which is minimum. It is Patna to Guwahati is minimum, and if SX score is SX score is higher from for every Guwahati SS exam, Northeast Meghalaya, Tiruchirappalli, every other data point has its SX score. And if the SS score will be highest, it will be the most probabilistic for the next cluster because it is the distance from its minimum. So it will obviously far from the maximum. If that minimum is maximum, if that minimum SX score is maximum, it will be obviously far from the maximum cluster. Okay, that is, I emphasized on this because it should be intuitive how it is defining the cluster K cluster mean intuitively. I have explained. I've tried to explain. Sorry if I have missed. I have not missed. I think I have not missed. But if I have tried my level best to explain all this. Means clustering is smart instance K plus means. This is smart installation. And first of all, I think I have to. Uh, if you wait for some time. Basically there is also a choice of K. मान लो कि अगर if you will take more case, if you will take K is equal to N, then every point will act act as a mean of its own cluster. K cluster, K mean, K points, K cluster. If K is equal to N points will be the mean of its own cluster. And no other points will be in that cluster because we have N points, we have assigned N clusters, we have chosen N, K is equal to N, and K cluster every point. So there should be a penalty or chosen choice of K because we have not till now discussed K. So this is the penalty. Basically, it has the graph. I have to explain the fast because time is out of. This is the K object plus penalty graph. K should be at this. Penalty is this. Objective is this. If K is equal to N, objective will decrease, and penalty has different values of penalty. This is the one penalty value. This is one penalty value. Penalty of K. Basically, it is a penalty. We will choose. It is dependent on the. It has not been well discussed. However, detailed evaluation of this criteria is beyond the scope of this course. Penalty. How penalty is chosen? You have not. You will give in penalty and you will calculate. You will draw this graph and see which K has the minimum object plus penalty value. Okay. Now, in fast, I will discuss the graded assignment. I think I have I have done good explanation. So graded assignment need not to be explained in very detailed manner. I will explain only. I will only uh, go with the fast. I will do it fast. If any doubt, you can ask in the comments. This is the we have discussed this. Basically, this is only this type. You can go there. What we have proved this. This will be best of which will be less. ZT plus 1 TIO plus 1 be third one will be the less. After that T plus 1. After that this is the answer. And after that, for every iteration the value of objective function is lesser. The value this will be the answer, the PT plus 1. And after with what respect Lloyd like choose at the end of k means the objective settles in the local minima. I have explained this in the during the session also. And if the resources are limited, data set is used, it will be good to prefer k means over k means plus plus, because assigning k data means are also is also a tedious task. So randomness when the point data set is used is okay. Basically all the points from all the points from left to L3 will be the assigned to this cluster 1. This will because it is it should be at perpendicular, all the points should be at all the lines should be perpendicular to each other. Yeah, it should have the equal angle. It's not be perpendicular, it should be, in the case of triangle it should be perpendicular, but it should have equal angle. So I think this has the equal angle. All other figures doesn't have the equal angle. Why this figure? Because for every cluster this will be the answer. This will be the answer because in Bornite region we choose the perpendicular bisector. Value with maximum score will be chosen. The next human mean we have discussed, it will be this. K means sensitive to cluster center centralization. K means sensitive to cluster centralization. Yes, it is an bad initialization can lead to poor convergence. We know random initialization uh, decide all things, and bad design can lead to bad double clustering. It is I have explained all three. This is all the answer. If data set 2 feature x1 x2 and following are 2 for K means clustering. If x1 and x2 correlation, the cluster center will be in straight line. Yes. I have a, one minute. Give me 1 minute. Basically, we know the Werner divisions are the half space we have read. Uh, Half space are perpendicular bisector of line joining the cluster centers. Half space are perpendicular bisector of line joining the cluster center. These are cluster centers. It is the perpendicular base. This will be the result of applying K means. Basically, if you apply K means, this all, if you calculate the distance, this all be the, because it will be perpendicular. Basically, I can explain. Its center will be have the direction in upward direction, and it should be the perpendicular to the half is perpendicular to the center. That's why it's the scenario. But here both the but here both the half centers and the cluster in the same direction upward. That's why this will be the answer. Ha. None of the cluster, it is not of the factor. There are the 3 points. Different cluster center initialization. Different clusters may reach in different clusters. As we have read, first initial random assignment can give different objective function, and different objective functions is proportional to different cluster orientations. Some instance may take more time to converge, and some instance may converge either in local minima or in global minima. It is dependent on the first random initialization. So we have in smart initialization K means plus plus, we have chosen better mean centers to uh, avoid that, and this all have no any relation. Now this is only left. We have the 7 data points. We want to form 3 cluster from this point. Assume that after first iteration C1, C2, 3, C3. Basically random K-means algorithm है, तो random initialization होगा. It will be random initialization. After second, which of the cluster of data point to expected to move on? कोई भी random assignment कर दो. We know this procedure, and I am being so. If you can ask me in the next class also, but I know what is the procedure. You can follow the same procedure as this. Firstly, random assign the cluster centers. Randomly assign any value from 1 to 4. 1 to 4 to this for every for example, randomly assign 1 2 1 3 2 1 2 1. Now calculate the mean of every cluster. First cluster mean is 0 4 0 4 4 0 4 0 4 2 2 6 6 9 9. Cluster. So sorry. We not to do this. It has already given that these all are the first random assignment. Now we have to calculate for every cluster the mean. 2 2 4 4 6 6. It will be equal to mean will be equal to 2 4 6 6 12. The mean will be equal to 6 6. First mean will be equal to 6 6. First mean is 6 6 for the cluster 1. Second mean is 2 2. Third mean is 7 7. Now calculate the minimum distance of 2 2 from each of the calculated mean, and minimum distance is 2 2 from 2 2. So it will be assigned to C2. New reassignment. So answer will be 2 2. Sorry, 2 2. Check C2. C2. Now every question has been answered. You can ask if any doubt. You can ask in the next doubt session. Thank you. I'm ending the meeting and I have to go for eat. Maybe I will not be given food. The time is past. Thank you.